Welcome everybody to the session that we are having here at the Agile Monkeys for our internal learning program. Hi Borja, how are you doing?
Hello, really good, really excited with all the learning that we have been going through.
Can you tell us about what were your first steps in the algorithms group?
The biggest research we have done is around these algorithms. One is PM25, the other one is BERT, and the final one we have looked at is ColBERT. First of all, there's a big difference between BM25 and BERT and ColBERT. BM25 is more a traditional algorithm in the sense that is keyword focused. So this algorithm, let me just round it here and say this is a keyword algorithm. And then you have BERT and ColBERT that have a semantic approach. And the big difference between a semantic approach and a keyword approach is that traditionally you would have this search approach where you have a query and you search term by term if any document in your database, document meaning any product or any information that you have in your database, has the exact same term. And this is quite good. It's quite fast and has worked for many years, but there's a big limitation with them, which is that you have to have the exact same term. There are many workarounds and there's a lot of work in order to overcome this big problem with keyword search. And I'd say semantic just improves or provides this nice solution for this big problem, because in semantic search you are not comparing term by term, but you're comparing an embedding, which is like a vector representation of the semantic meaning of each term.
So you were talking about the difference between BM25 and then the other two algorithms that are semantic. So what else can you tell me about these semantic algorithms?
Search as a concept, for me at least as a user, looked like a very complete, let's say, algorithm. But when we started researching and taking a deeper dive into search, we discovered that there are like many sub processes involved in the whole search pipeline. So before talking about that, I'd say that there's a key learning that I would like to share first in order to better understand the difference between BERT and ColBERT. There are many processes involved, and I'd say there are like two key and really different processes that you should tackle in really different ways. And those are retrieval and ranking. For example, a given query, I want a fruit. And here you would have your list of your database of items. What retrieval means is that you would get this query into your database, and then you would produce a subset of items that would relate to this query. So it's just to provide a list of possible items. This is what retrieval would mean. And then we would have the ranking side. And this could be over the whole database or over the subset. So it would be over a list of items, just sort them in a way that would be relevant for the given query. For example, having another example talking about, I don't know, a user that wants to search for a science fiction book. The retrieval side would be to include, I don't know, Star Wars within the subset that you provide to the user. And the ranking would be to have Star Wars over other kinds of books that are not as clear related to science fiction. These two are really interesting and important problems that you should tackle separately.
This you were talking because we were now talking about the semantic search algorithms. So there is when we start talking about the family of algorithms, there is BERT and then specifically ColBERT, right?
Yeah, I talked about all this because when we talk about BERT, it is more commonly used for ranking, so it will fall under these tasks. And then ColBERT is an extension of BERT. They use BERT underneath in order to perform these two tasks. So they extend BERT's capabilities of just ranking into being able to do a fully retrieval and ranking process at the same time. And yeah, there are many possibilities with that.
Besides the difference that we just saw from BERT and ColBERT, that is focusing more on ranking for BERT algorithm and then on both phases for ColBERT, would you say there is any other difference?
Yeah, so essentially ColBERT is created as an attempt of making the BERT type of search, but to make that exact same search in a much quicker way. Let me show you a image from the ColBERT paper. It's really visual. So on the first image, on the A figure, you would have the basic semantic search that most of us have done throughout the years since we have semantic search, which is generating an embedding of the query, generating embeddings from a document, and then just perform a semantic similarity search. This is a fine approach, but there are some limitations to it. So embeddings is just transforming a piece of text into a vector representation. And unfortunately, on that transformation, you are losing some meaning. So this approach, this really basic approach, when treating with documents that have different topics, doesn't work as well as it should because you are reducing the meaning of text that has a lot of different
Oh,
topics into a single vector. And that's what BERT models try to solve. They say, hey, what's the atomic form of meaning that cannot break? And they look for terms and even sentences because they assume that in a sentence it's really difficult to talk about different topics. Their approach is to essentially generate embeddings from each term in the query and from each term or sentence in a document, and they would perform a semantic similarity of all of them.
oh.
And this provides really interesting results, but the downside is that by doing so in the inference time, the user is losing some speed that other algorithms have.
Oh, I can imagine because you have to process the document sentence by sentence, not all at once.
That not only process and generate all these embeddings, but also compare them, which is a
Yeah.
really tough process.
So what else are we seeing in this image?
Yeah, the last algorithm, which is the one on the right side, is the one that the ColBERT authors propose, is to perform an embedding search between the query and the document before the re-ranking. We talked before on how BERT just performs ranking, and that is because it compares all the documents in the database with a query, and therefore it provides a list of items that you can then filter out by some threshold in the score that they provide for each document. But the ColBERT approach is that first you generate the document embeddings offline, so before releasing your application. And then what you do is you generate, when you have a query, you generate the embedding of that query and compare it to the already generated embeddings from all documents. And once you have the semantic similarity of all of them, you perform a maxim operation, which is basically getting those embeddings that have the maximum similarity with your query. You go to your database, retrieve the documents associated with these embeddings, and then perform a ranking just over those documents. So it would be a two-step process, first retrieval and then ranking, that would provide the similar results to the BERT model, but also in a really quick way.
So I wanted to ask you, were there any challenges that you had while you were setting up the experiment with Colbert?
Yeah, so the challenge or the biggest challenge that comes to my mind would be the holy grail in the AI world, I think, which is data or choosing the right data. So there are like standard databases for information retrieval, like the MS Marco and other ones. But we found out that these had like really clean data and with really well structured examples. It would provide like general knowledge questions. I don't know who was the president of whatever and whenever. Like it was a really well structured sentence. But what we would commonly found in e-commerce platforms when integrating search ourselves would be that queries are like a couple of words, like really straightforward, black dress. So what we wanted was this kind of data that mimics this real production environment, not only from the query perspective, but also from the data side that we could index. So yeah, data would be our biggest challenge, if not on any AI project.
Yeah, I feel like this is a very common challenge that everyone has to face when you're setting up an experiment or a proof of concept. You have to choose very well your source of data and then make sure that it makes sense for your use case.
Yeah, exactly. And what we did is research like everywhere. There's a platform called Kaggle, which is really interesting, as well as Hugging Face, which is another really interesting platform to get these kind of data sets that are built from the community for the community.
Could you show me an example of this?
Yep. Let me share my screen. This would be a competition that we found really interesting for the data side, which is the Home Depot product search relevance competition. If you don't know it, Home Depot is like a tools supplier, and their data that they provided for this competition is really interesting. They provide all these CSV files with product descriptions, titles, attributes, and all this data that you would normally find in an e-commerce database. And not only this was interesting from the product side, but also they provided a train CSV that would be commonly used to train whatever AI model, and we would use that to index and test our results. They provided a search term that users provided and also a relevance score that has been crowdsourced from many users. So this was a really nice way to experiment and test how search algorithms would work.
I feel like this is a very complete data set because you also have saved here the user interaction, so you can have the complete user flow for the search that they are performing.
Yeah, exactly. It was a really nice thing, and it also provided a nice way of evaluating our results.
So, would you be able to walk us through the results of your experiments?
Yeah, sure. I was trying to compare both BM25 in ColBERT and see by myself the results they provide. And meanwhile, I was also trying to validate an interesting hypothesis I had in my mind, which is that BM25 could be more suitable for shorter queries than ColBERT or other semantic approaches, because we would be leveraging on the speed of keyword search that is still faster than semantic approaches for these kinds of queries that don't have as many information and could be not as powerful for semantic approaches. And then we could use ColBERT for more complex queries that have more terms. Let me share with you my screen. So this is a graph that we created that summarizes these experiments. I would rather focus on the left graph, which I think it's more visual than the other side. This graph, what represents is the mean squared error of the relevance for each test case that we had for a given search term. And we just generated the score using BM25 in ColBERT to compare, and we compared and calculated the error, which is the difference between the expected relevance and the provided score. And we plotted that into a graph. So essentially, this graph shows that the PM25 is indeed a bit worse in terms of scoring accuracy than the Colbert one. And there are some fluctuations at the end of the graph, but I'd say to not focus on them either, because a exploratory data analysis was done and we discovered that there are not as many samples for queries over 6 terms. And then, yeah, what we see is that my hypothesis is not as validated for this use of BM25 for one word queries or two word queries ColBERT still performs PM25, but we still have to do a analysis in terms of the cost efficient of these two algorithms, in the sense of if PM25 provides good enough results for one or two word queries, it might be worth to use this algorithm for these queries since it's still faster than ColBERT.
So what you are proposing maybe for a next step would be to combine both algorithms depending on the search length or the query that the user is adding into the search bar.
Yeah, there are some cases that it's interesting to use this faster algorithm for these good enough cases and provide a enough result to the user. And there are other cases where you have to be really strict and you would prefer to spend a bit more time processing the query of the user and then provide better results.